Hi everyone, my name is Girish Manmadkar. I'm part of VMware CIBG business unit focusing on various AI solutions with partners like Kyndryl. You must have heard in the morning that we have few partners that we have started working with. Delivering a platform is one thing that we do really well, that you all know. But also in the private AI space, we want to make sure that we have the partner delivering additional value on top of it with various applications, various use cases, various models that they can execute it on top of it for you as a customer. So here with me, I have Venkat from Kyndryl as well as Pietro. They are going to go present and talk about how they have leveraged VMware Private AI Foundation stack to do a little bit more beyond what customer use cases are. And I think you will benefit more from them. So Venkat, all yours.
Thank you, Girish. Good afternoon, everyone. So basically, I'm going to take you through, what we have essentially done from the private AI standpoint, which you must have all already heard. Back in Las Vegas, a couple of months ago, VMware made an announcement on the private AI, specifically, providing the GenAI capability. So which is something that we essentially, took the private AI reference architecture. We built our own reference architecture based on that particular piece of work. And then we further implemented, the overall solution, and which is what we are going to get into. So essentially, a lot of our clients, as we look at, the AI has become an integral component of their overall, strategy from the digital transformation perspective, and which is something that they are adopting it, and trying to look at further from the traditional AI enterprise AI applications to more of Gen AI application or generative AI application. So what are the kind of key challenges that really need to be addressed, right? So the few things that we put it here from the perspective of, the data sovereignty, specifically addressing the data privacy, the data locality, the data access. So there need to be some kind of guardrails that we really need to put around that, right? Which is something that need to be essentially addressed. And then, based on where you run it, right, in terms of, how do you do the cost optimization, in terms of building your model, training your model, and then running your model, from on-prem to the public cloud, and then further, the technical debt. So the AI itself on the generative AI with all the complex stack that, you have, there are a lot of new tools, new components that are going to be brought forward as part of the solution. How do you essentially, maintain and manage, and then build the new applications, etc., right? So that essentially requires a lot of effort in terms of how do we address. And the other thing is the performance consideration aspect, which is really important from the GPU acceleration perspective. How do you optimize it in order to reduce the cost footprints or optimize the cost versus performance? So that is another dimension that need to be looked at. And last but not the least, primarily from the developer perspective, how do we improve the developer productivity, essentially by looking at various tooling to make acceleration from the applications development standpoint. So these are all the elements that need to be really kept in mind when you try and adopt and build these applications. So prior to, we looked at the GenAI components or GenAI stack, we have been implementing the AI and ML stack for the last couple of years, working with VMware and NVIDIA. As you can look at it from the top down, our approach and architecture is essentially looking at from the applications down to the infrastructure. And then, the platform for AI, how would you essentially provide that? So if you really look at it, from the applications perspective, you can have the traditional VM-driven applications or the more modernized applications which are containerized. So essentially, we need to be able to help support the Kubernetes platform, which is what we try to leverage here with the vSphere with Tanzu as the underlying foundation on top of the VMware VCF, VMware Cloud Foundation. And then with the NVIDIA Enterprise AI stack that contains all of the core components necessary to support your enterprise AI applications, and then provide the MLOps kind of services, with the TensorFlow, the PyTorch, etc. So further, as we look at, which is what you would have seen, in the morning, based on what Chris Wolf presented, this is the private AI reference architecture, which is something that VMware has essentially created. As you look at the previous stack that we have essentially built, this is just an addendum to what we already have. So we have, added our NVIDIA NeMo to that. In addition, all the large language models that need to be built are layered on top of the existing stack. So if you really look at, with NVIDIA NeMo, it is essentially the core NVIDIA AI Enterprise as the underlying foundation, right? So on top of which you have the NeMo framework that will support the large language models. So that's what we try to create, a reference architecture, which is something that Pedro is going to take you through. And then further, what are the services that we have essentially built around that framework, and then how you can leverage in the real environments. With that, Pedro.
Thanks, Venkat. Okay, can you hear me? Okay, good. So now I will deep dive a little bit more in the reference architecture that we did not create it, but that we are leveraging for our solution, together with a set of assets that we created for deploying, facilitating the deployment of the solution. So first of all, let me say that this reference architecture is not just for GenAI. We started developing this reference architecture several months ago for what we call the enterprise AI or predictive AI type of use cases that are essentially, the typical problems in classification or clustering, typical problems like, spam detection, prediction, this type of things. And then we have evolved to add the GenAI piece. Now, before we deep dive into the reference architecture, I don't know if you are already familiar with the difference between traditional AI and the GenAI. Just a couple of words, just to make clear which are the key drivers for GenAI with respect to the traditional AI. So, traditional AI, as I was saying, we are referring to machine learning algorithms or even deep learning algorithms, like the type of regression algorithms or k-mean algorithms, all these type of algorithms for machine learning, as well as algorithms for deep learning. But the key difference between these algorithms and the GenAI algorithms, because also the GenAI algorithms are based, if you want, on deep learning technologies, but the key difference is in the size of the training model. That makes a huge difference. Let's take the example of a simple algorithm for the prediction of the price of a house, right? So you have all your parameters. That is, the first one is the price of the house, and then you have other parameters like the size, the square meters, how many rooms, how many bathrooms, is there a garden, a terrace, these type of things. You get these parameters, you feed into your model, and then let's assume that you're using a linear regression model. With these parameters, you can fine-tune the function to predict, the prediction function. And then here, you are using something like a dozen of parameters, maybe 50 parameters, in the worst case, 100 parameters. With GenAI, we are talking of algorithms that are dealing with billions of parameters. So you need to think to matrix of billions of data that are ingested into the system and are processed by the several elements of a deep learning, of a neural network. So this requires, first of all, parallelisms, and second, hardware accelerations. If you think that the first large language models that was developed, these models was taking months to be trained for the first time. So this requires really a huge computation capability. So now, say that, let's see which are the key elements of our solution. So obviously the hardware. In the hardware part, the key element are the GPU cards and the network acceleration, network accelerated cards from NVIDIA. And on top of that, we have the virtualization layer with VMware that can be either based on vSphere or on VCF. Doesn't make so much difference. Then, obviously, once we have our virtualization layer, we can use either virtual machines or containers. We will see that containers are a critical part of the solution because they allow the scalability of the solution. And then, now that we have our, let's say, base infrastructure, then we need to leverage, we need to add the key components for the machine learning or GenAI modeling and training. And these are provided by the NVIDIA AI Enterprise framework that provides a set of services for the data ingestion, data preparation in general, for the data training, for the model training, as well as for the model optimization and running the model, that is the model inference. So these are the major capabilities provided by the NVIDIA AI Enterprise framework. NVIDIA Enterprise framework provides also a set of foundational models in many different areas. These are free, included into the NVIDIA AI Enterprise Suite. And then for the specific large language model, GenAI models, there is the NVIDIA NeMo, that is a framework that contains a lot of pre-trained models that you can use to generate, to fine-tune your own models. So you can use this as a starting point. And then there are also other capabilities like, for example, the NeMo guardrails that allows you to make sure that your model is stick to particular rules and doesn't derail from particular rules. Then finally, Kubeflow. Kubeflow is also an important element of the architecture because this allows you to implement what is called MLOps. It's the equivalent of DevOps for machine learning, right? And it's very important because it allows you to automate the different phases in the creation of your GenAI and AI application. And finally, you can eventually leverage open source models from Hugging Face or Llama 2, whatever you want to use. So now let's see how these are deployed. Obviously, we don't need all the components everywhere. If, for example, if we want just to run the inferences, so if we want to evaluate your model in an edge location, we just need very tiny components that will be run at the edge location. It's different if we want to run, for example, the training or the fine-tuning for a large language model, because this will require a considerable amount of resources. So this is something that you cannot run at your edge site. This is something that you need to run on your data center. So depending which type of capabilities you want to run, we will deploy different components in the different locations, right? So now let's see which are these components. Okay, here the base are ESXi hosts, right? And the NVIDIA GPU cards and NVIDIA DPUs. So the first thing that we do is we install the NVIDIA drivers on the ESXi hosts to make sure that the ESXi host is able to recognize and work with the GPUs and the network accelerated cards. Once this is done, the SXI hosts are ready to host either a vSphere environment, I mean, you don't need a VCF environment, or if you want to use, for example, hyperconverged storage, you can use vSAN. In this case, we recommend to use vSAN 8 ESA because it provides better performance, especially for GenAI. Or if you are dealing with huge quantity of training data, in this case, it's recommended to use external storage, maybe some object storage where you can keep this data, because it depends on the size of the data, obviously. But vSAN ESI is a very convenient and very fast storage for doing the training. For what concerns the networking, as I say, this works with plain vSphere, so either with the VDS vSphere networking or with NSXT. Let's say that from a solution perspective, doesn't make so much difference if you're using VDS or NSXT. Okay, now we have the vSphere environment. This is prepared to leverage the accelerated hardware. Then at this point, we can create directly what we call the deep learning, are called the deep learning VMs, that are VMs enabled for the accelerated hardware, so they are configured to take advantage of the GPUs and the DPUs. And on top of that, we deploy the NVIDIA AI framework, the NeMo framework, if you want to run GenAI applications. And so this is one way of setting up your environment. You create a deep learning VM, you have everything you need to run your AI applications, to train or run your AI applications or GenAI applications. The other way that we recommend is to use Tanzu, so to use containers. The reason behind that is because containers are more scalable, right? And so are better suited for parallel processing type of processing, especially for GenAI applications. So in this case, the vSphere with Tanzu is enabled to take advantage of the GPUs, right? So we need to create particular VM classes for the workload clusters to leverage the GPUs. And then on top of that, as containers, we can deploy the NVIDIA AI Enterprise, all the components of the NVIDIA AI Enterprise that you see in green on the right part, including the NeMo framework, and then TensorFlow, PyTorch, Triton, NeMo guardrails, whatever is included into the AI Enterprise can be deployed there. Then, always as a containerized application, we deploy the Kubeflow in a separate cluster, and this can manage the MLOps operations in your environment. And then another important component is the Ray cluster. Ray is an application that makes, is used to parallelize Python code. So it's very, very used, much used by the in the machine learning development phases. Okay, and then on top of that, we can plug also the traditional open source models that are used for GenAI. Okay, very quickly, the added value that we are providing is that we have automated almost all the phases of the deployment and configuration of this environment. Of the previous picture that you have seen, like, for example, we have automated via Ansible, using some Ansible automations, the preparation of the ESXi, the creation of the templates, the creation of the Tanzu cluster enabled for GPUs, the deployment on NVIDIA AI Enterprise, the different operators deployment, up to the installation and configuration of MLOps for your environment. So, everything is automated, and to set up this type of environment, we can do this in less than 1 hour, well, a little bit more, but, in a very few time. If you need to do that from scratch, it takes really a significant amount of time. Okay, so these are the assets that we have developed and that we use internally for ourselves, let's say, in our customer engagements to facilitate the implementation at some particular customers. This includes obviously a reference architecture that can be customized for the specific customer needs, automation scripts. These are mostly Ansible based, right? And deployment guides, either manually to implement the solution and configure the solution manually, or automatically via the automations, and then bill of materials and some promotional video. Okay, then now I give back the stage to Venkat.
Yeah. So thanks, Pedro. So a couple of things. So first of all, Kyndryl's private AI reference architecture has been officially approved by VMware. And in fact, if you have heard earlier today in Chris Wolf's keynote, he already mentioned about that, like we are part of the AI, private AI ecosystem. And in fact, the automation to build the entire stack that, that reference architecture, I think, which is very important from a repeatability standpoint, right? And to avoid a lot of errors while you deploy and run your applications and you build your applications, you want that process to be very, very simplified. So we have the entire, automation pretty much available, at the push of a button. But I think that is key in terms of our capabilities that we bring in, right, for helping you if you wanted to deploy, manage that infrastructure and then the application and the services. Along with that, like the data foundation, the MLOps service from the large language model standpoint, these are all very critical. So Kyndryl can provide the services end to end from the life cycle perspective, from the consulting, implementation, and the modernization. Any applications you have, we will go and then modernize those applications, because that is essentially where the Tanzu Kubernetes really come into picture, and which is something that we have full set of assets even with Tanzu application platform. Essentially, that will support some of these applications to run on top of it. So bottom line, end to end, we provide these services across the entire life cycle from application down to the infrastructure. And lastly, since this is a complex, kind of an environment, and the GenAI, it takes a village to really bring these services, right? So the partner ecosystem and the assets that we have, the skill sets, which is something that we as Kyndryl bring to the table from the perspective of, the assets that Pedro talked about from the automation standpoint, and the reference architecture, which is absolutely critical, because that's what helps to address some of the challenges that I have outlined in the beginning of the this thing. And then we bring the alliance partners, like NVIDIA and then other ISV partners, to really work together to solve your end-to-end problems. So with that, I will open up to any questions that you have. No question. Okay. Sounds good. Thank you very much.
Thank you.